All right, so with multiplying and dividing, we're doing the same thing we did with adding and subtracting. So we need to isolate the variable by the inverse operation. Excuse me. So for multiplication, what would be our inverse operation? Division. And then with division, it would be multiplication. Okay? So one thing I want you to remember about this is that a fraction shows division. Okay? If we have, let's say we take a pizza and we are dividing it out and you get a piece, you're getting a fraction of that pizza. So a fraction shows the same thing as division. And that's important because when we write equations using division, we're going to be using a fraction. Okay? So if I were to read this one, this is saying our variable divided by 15 is equal to 9. Okay? So I'm going to rewrite this just so it's a little bit neater so you can see exactly what I'm going to write. So how do I undo this division equation? What do I do? Multiply. What number do I want to get rid of? 15. Okay, so I'm going to multiply, and I'm going to use parentheses to show my multiplication. I'm going to multiply both sides by 15. Hey, guys, we're not done. Don't say the dreaded phrase, I don't get it.
Oh, sorry.
Okay? So, hey, we're not even all the way through an entire problem. Hold tight. Just because you don't understand in the first 5 milliseconds doesn't mean we give up. We're going to persevere. All right, so if I have 15 times P over 15, what is 15 over 15? 1. And what is 1 times P?
15.
P, okay? It stays the same. So that cancels that out and leaves me with just my variable. Okay? Now, I look at the other side, and what is 9 times 15? 135. Okay. Yes?
So, can I do the next one?
No, hold on, I'm not done. I got to check it. Okay, so when we check this, I'm going to plug this back in for our variable. So 135 divided by 15 is supposed to equal 9. So if we look at this, if I did, that'd be 45, carry my 4, yes. So that does give me 135. So my solution works. Okay?
You did 135 over 15. Is that divide?
That's why we wrote this up here. Fraction means division. And that's when I read this one, our variable divided by 15. Yes, this means to divide.
Can we just like multiply the two numbers?
Guys, if you don't write it out like this, love you dearly, but I'm going to have to count it wrong. Because remember, we said some of this is mental math. I get it. But what we're learning right now is the process of making our brains think in algebra, in that, you remember that mathematical language of algebra? We're learning how to train our brains to think algebraically.
I get this one.
Good. Okay? Yes.
Can you tell me how you like crossed out?
Yes. Let's do this one, and I'm going to walk through it a little bit slower, okay? So we have y divided by 17. Okay, I'm going to rewrite it just so we have more room. Now, if this is division, how do I undo it? Multiplication. And remember, since this is a fraction, this may help you a little bit more. I can do 17 over 1, and it's still equal 17, right?
Yeah.
Okay, you remember how we used to cross cancel?
Mm-hmm.
Don't those cancel out?
Yes. Yeah, and then the y times 1 equals y.
Why?
Okay, I get it now.
That's it. Okay? So I'm going to multiply both sides by 17. And remember, this means the same thing as this.
Do we have to do 17 over 1, or can we just...
You can just put 17.
I just get it.
Yeah, you can. I just wanted to make sure he understood where I was going. So what is y equal to?
Y.
Yeah, 170. Okay? So now when we check it, we're going to plug this value in for y. So 170 divided by 17 would give me 10. And we all know, using our powers of 10, that that would be correct. So yes, our solution works. Better? Okay. All right, let's do the next one. Again, I'm going to rewrite it just because those are kind of tiny and it's hard to see. Okay, so I have b divided by 12 is equal to 15. So how do I undo division? Multiply. And what number do I want to get rid of? 12. So I'm going to multiply both sides by 12. That cancels out. So what would b be equal to? 180. Excellent. Okay. And if we plug that in, that would be 180 divided by 12. And guys, if you want to, have you just a little sheet of scratch paper handy so that when you go through and check these things, we actually had one earlier today when we were checking. We had gotten it wrong. So we got 180 divided by 12. 12 goes into 18 one time. I have 6 left over. 12 goes into 65 times. So our solution works. Okay? We're not going to do all 6 of these. What I want us to do, we're going to do number 4. I just want to show you one with decimals. Okay? The other 2 are decimals too, but it's no different. I just realized we got some cobwebs where our operations with decimals are. Yes?
Does it work on division?
Yeah, we'll get there in a second. We'll get there in a second, okay? So here we go. So we have 4.7 is equal to r divided by 5. Does it matter that my variable is now on this side? No, okay? Because that equal sign, they can like go back and forth. All right, so what number do I want to get rid of? 5. So I'm going to multiply both sides by 5. And r would be equal to... So it would be, remember, even with decimals, 23.5, yeah. I think what y'all were trying to do when you were doing it mentally, you were trying to make it a 20 your whole number and then 35 your decimal, but you got to carry your 3.
Same exact thing.
Yeah.
Just multiplying with decimals.
Bingo. That's it. So we have this. So if we want to double check it, 4.7 is equal to 23.5 divided by 5. Now remember when we're dividing with decimals, guys, if I have 23.5 divided by 5, I don't have anything to move here, so I bring my decimal straight up. 5 goes into 20 4 times. I have 35, so that would be 4.7. So yes, it works.
Can you go over the 15s?
Oh, we're not there yet. We're not there yet. Okay. Just hold on. We've only just taken care of division. That is only 1/2 of the picture. Okay? Okay, so looking at number 7. Now we're going to look at the other side of the picture. Okay? 15s. What does that mean? 15 times s. So if this is a multiplication equation, how do I undo it? Division. Now, I like the way that mathematically they have you do these equations because it would look really awkward for me to come down here and like put a division sign and put 15. It would just look weird, okay? So we want things as neat as possible. So that's why we're going to use the fraction bar to show division. So we're going to divide both sides by 15. Okay? Well, as we said earlier, what is 15 over 15? 1, not 0. What is 15 divided by 15? 1. Not 15 minus 15. So these cancel each other out. That leaves us with s. And what would s be equal to?
S would be equal to 1.
Right. It would be 120 divided by 15.
Which would be
8. Very good.
Yes, that's what it is.
It's okay. It's okay. Now, if we go back and check this, that's what we're going to have 15 times. I'm going to plug 8 in for S. 120. And then, guys, look. 8 times 5 is 40. Carry my 4. 8 times 1 is 8 plus 4 would be 12. So our solution works. I did it in my mind. I did 8 times 5 gave me 40, so I put my 0. And mentally carried my 4. So 8 times 1 is 8 plus 4 would be 12. Yeah. I just multiplied in my head, kind of. Yes.
I always figured out it was 8, because I know, like, because 120, if you take away the 0, it's 12. So if you multiply 15 times 2, then it's 30. Then you just take away that.
Very cool.
Then it's 4, so then you double the answer.
I'm following a lot of paths in your head right now. All right, let's look at number 8. Hold on. Now, before you yell that the answer is 7, hey, Anna, put that up right now. Okay, it's not 7. What number do I want to get rid of here? 35. So I'm going to divide both sides by 35. Okay? Q is equal to. Now, don't jump at the fact that you have to divide this, because look, when I divided this is an improper fraction, right? Do I have an improper fraction right here? No. Can I simplify it?
Yes.
What there you go. The sooner, guys, that you realize how much fractions and division tie in together, when you're dividing, it's simply changing an improper fraction into a mixed number. That's all you're doing. So when we did that, it happened to come out to a whole number. On this one, it was not improper, so when I simplified it, I left it as 1/7. Now let's check it. So we have 35 times 1/7 is equal to 5. And remember, I know that 35 as a fraction would be 35 over 1. So what is 35 times 1?
35.
What is 1 times 7? Is 35 over 7 equal to 5?
Yes.
Then our solution works. Okay, now, on the next two that I'm going to do, I need your 100% attention, because these are the two that are a little bit different. Okay? Why do you think they're going to be different now? Not because they have variables. All these have variables. We now have a fraction. So hands down, just listen to me carefully. This is still a multiplication equation. We are still going to solve it using division. So what number do I want to get rid of here? 5, 6. So when I do 5, 6 divided by 5, 6, can I divide like this? What is my rule for fractions and division? I have to keep, change, and flip. Does anybody remember the fancy word for the flip? Reciprocal. Excellent. So, what we are going to do, when you have fractions and it's a multiplication equation, yes, technically we are dividing, but we know in reality, what we end up doing is multiplying by the flip, or the reciprocal. So if I have 5, 6 times k, I'm going to cancel this out by multiplying it by 6/5. Okay?
When you were trying to cancel,
hang on. Because what was my definition of a reciprocal? It is. But the reciprocal of a fraction, when I multiply them together, what do I get as my product? 1. And I always get 1. And here's why. When I flip this, what is 6 times 5?
30.
What is 5 times 6?
30.
What's 30 over 30? What's 1 times k? K. Remember, identity property, it keeps its identity. So by multiplying by the flip, that's how we get rid of that number next to our variable. And what we did to one side, we have to do the same to the other. So what is 1 times 6? And what is 6 times 5?
30.
Okay? I'm fine if you want to leave it like this, or if you want to simplify to 1/5. Either way, I'm good. Okay? I'm not going to take off or anything if you don't simplify on this. Because really and truly, our variable could be equal to either of those values. Okay? Well, that's exactly right. Although this one actually is a little bit easier to check when you do simplify. So if we go back and we say 5/6 times 1/5, we need it to equal 1/6. And this is where, Anna, were you saying earlier, can I cross cancel? Yes. So what is 1 times 1? And 6 times 1. So our solution works. So guys, this is the only one that's different, okay? This is the only one that kind of runs around the rule a little bit. Because when we divide fractions, we're not really dividing. We're really multiplying, but we're multiplying by the reciprocal. Yes?
This reminds me of like in those movies where there's like a bunch of roads and then like there's only one road to go on, and you gotta follow it.
Okay, here we go. Let's look at the next one, okay? Now, the reason I want to do this one is now we've got another thing that's a little bit different.
We have a mixed number.
We have a mixed number. Think back to fractions. What do I have to do to that mixed number before I can do anything? I've got to make it improper fraction. So what is 1 times 3?
3.
Plus 2?
5.
So 5 over 3 times m is equal to 15. Okay. Now, it's a multiplication equation. What number do I want to get rid of? 5/3. It's with my variable. So I'm going to get rid of it by multiplying by the reciprocal. Okay? Do the same to both sides. And when you were talking about cross-canceling earlier, do these cross-cancel? Yup. Do those? Yup. So all we have left is our variable.
How'd you get 3/5?
Because I'm multiplying by the reciprocal. Remember, if I do 5/3 divided by 5/3, and my rule for division is keep, change, flip.
That's 1.
That's my goal. 1. 3 times 5 is 15. 5 times 3 is 15. And 1 times m is n. M is m. That's my goal, is to completely get rid of that fraction. Yes?
Where did you get 5/3 from 1 and 2/3?
1 times 3 plus 2 gives me my numerator. Denominator stays the same. Even if you went the same way.
But can't you do 2 times 1 plus 2?
Yeah.
Okay.
Well, no, you could do 3 times 1 plus 2. As long as you multiply your whole number by your denominator and add your numerator. You're just changing it to an improper fraction. Okay? So now, what is 15 times 3?
15 times
45. And my denominator stays 5. So what would that be? 9. M would be equal to 9. So now we can check it. We have 5/3 times 9. I'm going to go and put it over 1 because we know it's the same value. All right. What's 5 times 9? 45. And what's 3 times 1?
3.
And 45 divided by 3 gives me 15. Okay. We're going to do a couple more together. What time is it? 2:35? Okay. All right. Do me a favor. Go ahead and flip to the back. Now, the great thing is, everything you're doing for homework, guys, you have an example on the back. Okay? And there's only 12 that you need to do. They are mixed up, multiplying and dividing. So the first question you need to ask yourself is, what is this equation? This is multiplying. So we undo it by dividing. So I'm going to divide both sides by what number? 3. Okay, that cancels out, so A would equal 6. And then we can go back and check it by saying 3 times 6 equals 18, and that's mental math, so we should know that our solution is correct. The biggest thing when you realize, look at these, when you have the fractions, when your variable is part of the fraction itself, that's division, okay? So when your variable is like your numerator of your fraction, see, like that one would be division, But if I look down here, is my variable part of the fraction? No, it's next to the fraction. So this one would be multiplication. Okay? This one's division, this one's multiplication. Is whenever your variable is part of your fraction, that means it's division. Alright, so how would we undo this division equation? Multiply. What number are we going to multiply by? 4. So we're going to multiply by 4 on both sides. That cancels that out. So what would B be equal to?
3.
What's 12 times 4, guys? 48.
4 times 12 equals 48.
Yes. Now let's check it. And this would be one of those things. If you had said 3, just not thinking, and I plugged it in as 3 divided by 4, do I get 12? No. So that's why checking it helps us. So we've got 48 divided by 4. Is that equal to 12?
Yes.
So we are good. All right, let's skip down just a little bit. Let's look at this one. 4/5 n is equal to 2/7. Okay? So again, what kind of equation is this? Multiplication. Remember, it's only division if your variable is part of the actual fraction. When your fraction is next to your variable, that means you're multiplying. Okay? So how am I going to undo that equation?
You divide it and then you flip and have the reciprocal and multiply by
Bingo. Excellent job. Multiply by the reciprocal. Okay, so I'm going to do that to both sides. Okay, this cancels this one out. So what do I have left over here? Just n. Okay, so now I can multiply straight across. What's 2 times 5?
10.
And 7 times 4? 28. We could simplify that. What would we get? 5/14. That might be easier to check. Who knows? Those bigger numbers may be harder. All right, let's see if it works. So we got 4/5 times 5/14 is equal to 2/7. Do I have anything there in cancel to make it easier? The 5s. So then I get 4/14. Is that the same as 2/7?
Yes.
You betcha.
I'm confused.
Yeah. Which one? Why did I what now? Because I can cross cancel just to make my simplifying easier. I could have gone straight across and done 20/70 and then drop my zeros and get 2/7.
Or you could have simplified.
4 and 14. Just remember when we multiplied fractions and we did cross canceling? That's all I did. And I did the 5s because these would both become 1s. So 4 times 1 would be 4, and 1 times 14 would be 14. Does that help a little bit? But even if you didn't cross cancel, if I just went straight across, that would be 20/70, which then we can drop both our zeros and it'd be 2/7. Okay?
48 equals 6/5.
Which one? That's actually multiplication, so how are you going to solve it? They're not division, they're multiplication. How are you solving them though? That's the thing you need to think about. This is a multiplication equation, but how do you solve it? By division. Yeah, but this is actually a multiplication equation. You are going to do division to undo it because you're doing the inverse operation. So what would you do to both sides? Not multiply. Divide by 6. Okay? That's division. So how am I going to undo it? Multiply by, yeah. That's division. Remember, anytime your variable is part of your fraction, it's going to be division. Yeah, you got it. All right, great job, guys.